The second subtopic is called 9.2 Rules of Differentiation. So, how do we write the derivative of different types of functions? Say, for example, if we have function y, or fx, or even gt. When you differentiate y, we usually write dy over dx. So, only for y is different from the other function. Other than y, all of them will usually use prime symbol. For example, if you have fx, when you differentiate fx, you will get f prime x. Now, let's say if we have gt. Gt means it is a function with respect to t. For example, maybe if you have gt equal to 2t squared plus t. So, if we differentiate gt, its derivative is g prime t. So that is how you write the derivative of different types of function. So, what are some of the rules of differentiation? Let's start with the first one, which is derivative of a constant. Say that you have a function fx equal to k, where k is a constant. Therefore, when you differentiate fx, you will get f prime x. Now, what if you differentiate the constant k? If you differentiate a constant, that will give you 0. So let's look at example 3, question A, where we have fx equal to ln 8. So if we put this into calculator, ln 8 is 2.08 and this is a constant. So when it is a constant, if you differentiate a constant, that will give you 0. And hence, this is f prime x equal to 0. For question B, we have fx equal to negative 1 over 2e cubed. So this one is also a constant. Using calculator, negative 1 over 2e cubed is negative 0.02. So it is a constant. And hence, the derivative is f prime x equal to 0. The next one is derivative of kx to the power of n. So say that we have this function fx equal to kx to the power of n. So we need to find its derivative. When you differentiate fx, you will get f prime x. Now, what if you differentiate kx to the power of n? K here is constant. So if you have constant as the coefficient, so this is the coefficient. When you differentiate, the constant stays the same at the front. Next, look at this power here. You bring it to the front and you times it with k. So you'll get k times n. And then you have x to the power of n. So x stays the same. But now, the power will minus 1. So now the power is n minus 1. Therefore, when you differentiate kx to the power of n, you'll get kn x to the power of n minus 1. So, if we look at example 4, we need to find the derivative of the following function. For question A, we have fx equal to negative x to the power of 11, and we want to differentiate this equation. When you differentiate fx, that will give you f prime x. Now, let's differentiate negative x to the power of 11. Negative here is a constant, it's a negative 1. So, put negative 1 here. Or you can simply write it as negative sign only. Now, what about x to the power of 11? The power is 11, you bring it to the front. So, you'll times negative with 11. So, what happens to x to the power of 11? X stays the same, but the power now, which is 11, you need to minus it with 1. So you'll get 10. Therefore, this is actually negative 11x to the power of 10. For question B, we have fx equal to 2 over x to the power of 4. So, if you have a constant k in the numerator and x in the denominator, change this so that it can be written in the form of kx to the power of n. So let's recall, if you have 1 over x squared, this can be written as x to the power of negative 2. If you have 2 over x cubed, this can be written as 2x to the power of negative 3. So how do you write this? This is actually 2x to the power of negative 4. So this is still fx. You haven't found f prime x. You are just rewriting fx in a simpler form, which is this one. So now let's differentiate this fx. Differentiate fx, that will give you f prime x. So if we differentiate 2x to the power of 4, negative 4, sorry. 2 is the constant here, so just copy down 2. Next, we have x to the power of negative 4. You bring power to the front. So now what happens to x to the power of 4? X stays the same, but now for the power, you need to minus with 1. So you'll get x to the power of negative 5. And hence, the final answer is negative 8x to the power of negative 5. But for the final answer, you cannot have negative sign in power. So x to the power of negative 5 is actually 1 over x to the power of 5. So this is actually negative 8 times 1 over x to the power of 5, which is negative 8 over x to the power of 5. So that's the final answer for question B. Now let's try for question C. This one you need to be very careful. Here you have this set. So this is actually 1 over 2. This is x to the power of 4 over 3. This is not 2 cubed times square root of x to the power of 4. This is wrong. This 3 here means this is 2 times cube root of x to the power of 4. So that's why you will get 2x to the power of 4 over 3. This is still fx. We haven't found f prime x yet. This can actually be rewritten in the form of kx to the power of n. So, k is the constant. If you look at this expression here, the constant is 1 over 2. So, this x should be rearranged to get in the form of xn. So, this is actually 1 over 2 x to the power of negative 4 over 3. So now we can differentiate. We actually want to differentiate this function. Now let's differentiate 1 over 2x to the power of negative 4 over 3. The coefficient is 1 over 2, so it stays the same. Next, we have x to the power of negative 4 over 3. So bring power to the front. So what happens to x to the power of negative 4 over 3? It will become x to the power of, for the power, you need to minus it with 1. So the new power is negative 7 over 3. So let's simplify everything. You'll get negative 2 over 3 times x to the power of negative 7 over 3. As per usual, final answer cannot have negative in the power. So this is actually 1 over x to the power of 7 over 3. So by simplifying, your final answer should be negative 2 over 3x to the power of 7 over 3. And that is the final answer for question C.